Welcome everyone to this StarkWare Exploration Team tutorial. Today we're going to present the Broly project, and I'm welcomed here with Lana from the Exploration team. Broly is an inscription service that uses Starknet for order book management. It's a very unique application because it taps into the Bitcoin ecosystem, and it's enabled with various dev tools that have been built within the Starknet ecosystem, namely Utu Relay and Raito. And so in this video, we're going to go over what Broly is, the application itself and how it works, and how the creation of an inscription on Bitcoin works from a user's perspective on Starknet. And then afterwards, we also go into how this application is enabled with dev tools such as Utu Relay and Raito. But first, I'm going to give the stage to Lana, and she's going to give an overview of how Broly works. And afterwards, we're going to actually create an inscription. And finally, we're going to explain the dev tools that enable you to build Bitcoin applications on Starknet.
Fantastic. Thanks, Victor. Hi, everyone. My name is Lana. I am part of the exploration team at StarkWare. And yeah, for the past couple of months, I've been heavily involved in our cross applications between Bitcoin and Starknet. And I'd like to present you Broly. So first of all, I'd like to say a couple of words of what inscriptions are. If you come from the Ethereum ecosystem, you probably don't know what inscriptions are, but they're actually quite similar to NFTs. How they work in Bitcoin is every Satoshi in the ecosystem, and one Bitcoin is 100 million Satoshis, so every Satoshi is numbered. And you can point some data to that Satoshi. So you can actually create a very large number of inscriptions. And yeah, as long as you own the Satoshi to which this inscribed data is pointing to, then you're the owner of this data, of this NFT, so-called, right? So this inscription. What is actually Broly doing? It allows a user who has funds only on Starknet to get something inscribed on Bitcoin. The flow is like so. So as a requester, that will be Victor in our demo. You come to the Broly website and you create a request. So you choose either some text data or emojis, and some fee is locked, so some STRK, and your Bitcoin address. So even though you don't need any Bitcoin, you do need a Bitcoin address, so you need the Xverse wallet extension installed. So the address will be automatically pulled from your wallet, and all of this will be stored in a Broly contract as an open request, and you will see it on the Broly website. So after that, the Starknet user can just kick back and relax, and submitters who will be running the inscription service. As soon as this event is emitted, the submitter picks up this data, and what they can do is they can lock this inscription. It means that they will say that, hey, this is me with my Starknet address, and I will inscribe this data and then prove it to you. So this lock is valid for 100 Starknet blocks. This is actually hard-coded, but this can definitely become a variable parameter. But it means that in this 100 blocks, another submitter cannot lock this request. And if this first submitter doesn't inscribe it, well, then 100 blocks later, another submitter can come, lock it, and get the locked Stark fee, the one that was locked here. So here, everything that's blue, this is interaction with Bitcoin. So using the ORD CLI, we send a transaction with the data inscription to Bitcoin. This actually happens in one command with ORD. So you specify the destination address, which will be this Bitcoin address fetched from Xverse, and you specify a number of Satoshis. This is kind of like a dust amount that has to come along with the inscription, so that in the future, the requester, the user, would be able to use this UTXO and pay fees and set this inscription further if they need to. So we get back a transaction hash, a Bitcoin transaction hash that has the data in the witness field, and the owner becomes the Bitcoin address of the requester. So after that, we register the block with the Utu Relay contract. The Utu Relay contract is a smart contract that allows Starknet users to maintain the Bitcoin canonical chain. So what happens there is that you come to the contract, you say, please register these headers. It verifies that the headers are correct. After that, you can optimistically dispute the canonical chain. So if you can bring a longer chain later with more proof of work, then you can actually dispute the correctness of this chain. So because this is not production level yet, so this is a proof of concept. So right now we don't have this feature implemented yet, but in the future this will be possible for the user to say how long they want to wait before they can be sure that the block that the submitter is bringing is really part of the canonical chain. But right now, we just assume that everything happens well. After you've updated this canonical chain, so we've built another contract called the transaction inclusion contract, which checks that this transaction is actually part of this Bitcoin block, so that the Merkle tree actually hashes to the correct root, and this data is pulled from the Bitcoin provider using the Bitcoin on Starknet library. So you pull all the paths and all the proofs from the Bitcoin provider, and then you can prove that the transaction was included correctly. After we are sure that the transaction is part of the block and the block is part of the Bitcoin blockchain, we return the check. We say that it's correct. And the last library that's also been actually developed in the exploration team is Raito. Raito is the Bitcoin consensus client developed in Cairo. Raito is a Bitcoin-like client. It implements the same logic as Bitcoin Core, and you can use to much faster a Bitcoin node and convince yourself of a correct Bitcoin state and correct transitions. So we use some of the Raito codebase in Utu Relay also, but Raito is a very special project in the sense that it unlocks use cases for the Bitcoin ecosystem. Yeah, it allows to prove Bitcoin state transitions rather than rerunning everything how we're usually used to in blockchain in general. After we convinced ourselves of all these things, we go back to the Broly contract and we send it the transaction hash and the ID. Then we do some internal checks. We say, okay, well, is the receiver address correct? Does the transaction witness data contain the correct data that was requested here? And then the fee gets transferred from the Broly contract to the submitter. Multiple submitters can run the service, and at the end of the day, what did we get? So the requester just paid some STRK, and now they're a happy owner of this inscription on Bitcoin, and the submitter submitted it on Bitcoin and got some STRK for it. At the moment, we don't really have an incentive system implemented. So we fetch the price from an API to get Bitcoin to STRK price, and the submitter gets the fee. So whatever they paid in Bitcoin, they get the STRK back. But in the future, it would also, of course, be very nice to implement a good incentive system where a requester can add a significant fee on top for submitters.
Okay, so now we're going to actually create an inscription. So I'll share my screen. First, I'm going to link my Xers wallet. My Argent wallet is also connected, and I'm going to inscribe, let's say, a lemon emoji. So now I will confirm this transaction.
Okay, nice. So now we see waiting for inscriptor. So if you run the service, it will happen automatically, but I will actually just show you the flow, what happens under the hood with all the scripts. So here's Victor's lemon, and as an inscriber, I have to first of all, so I can actually see some information about this inscription. So I can see here the data, and I can see that it hasn't been locked yet. So query inscription lock tells us information about who inscribed it. So I'm going to quickly connect to wallet on StarkScan. And I'm going to lock his inscription. And now here we should be able to see that the inscriber, the submitter, accepted. Yeah, so now Victor doesn't have to do anything, and I will inscribe this on Bitcoin. Okay, so here I have the ORD software running. So we have a Bitcoin node running, and you can connect to a node via RPC. I can check my addresses. We can see like which outputs we have, how much satoshis we have locked in there.
And what does this ORD server actually do?
The ORD server allows you to communicate with a Bitcoin node and to use, send, and create inscriptions. So you can see your balances, you can create runes inscriptions, burn them, manage your wallets, and do a lot of stuff that you would normally only be able to do with a front end like OrdiScan. So there's not a lot of CLIs out there, and ORD helps with this. Cool. So let's inscribe. So the file would be lemon.txt. So fee rate is a flag that says how many satoshis per byte you're going to pay. You can put 1, 2, or 3. I put a bit 3 because it's a bit higher to reward the miner. And I need to grab Victor's address. And postage is how many satoshis we will include in this transaction as dust. So send.
And what is dust in Bitcoin?
If you send an inscription without postage, you're going to have an inscription sitting there stuck without being able to send it. So you need to make sure that you have some money in it. So when you send a transaction like this, so destination, just make sure that it arrives at the correct address. So the reveal is the Bitcoin transaction hash. So let's go to mempool and search for it. So here we see Victor's address, the 546 BTC, and we'll have to wait a bit for the transaction to be included. So here we have the transaction confirmed. And mind you, you don't need to do any of this when you're running the software. It's all going to do it on its own. But you copy the hash, and we are going to use the Bitcoin on Starknet GS library. It's been adapted to fetch the data that we need for all the proofs. So what we do is we update the canonical chain with this hash to Utu relay. So it takes a few seconds. So it fetches the block height from the Coinbase transaction. And after this, we submit the inscription. So this is already sending to the Broly contract on Starknet. What we should see is request complete. And what I will see in my wallet is that I got the Stark that was taken from Victor. Now it came to me. And now in Broly, we see the lemon inscribed. Yeah, there you go. Here's your lemon. If you go to your inscriptions, yeah, so you see the Satoshi, you see when it was minted, the rarity of the Satoshis. Yeah, if you click OrdiScan, it should take you to information about this inscription on OrdiScan. Yeah, OrdiScan is a website with which you can interact and find inscriptions, runes. So in your own time, you can poke around the website and read about what rare Satoshis are.
Okay, so this was the tutorial for Broly, and now we move into the final part of today's video. We are going to look into what Raito is and what Utu Relay is. Lana, do you want to share your screen, show the repository, and give us an overview of how each of these dev tools work and what people can do with them?
As part of our efforts to work with the Bitcoin ecosystem, so the exploration team and the LFG Labs teams have developed several really useful libraries, and I welcome developers to look around and come up with other good use cases. So as we mentioned, Utu Relay is a smart contract that enables secure verification of Bitcoin transactions, and we maintain the canonical chain. And what would be a great security property is fraud detection. So you should be able to challenge block. And what is an interesting question to think about is how you can incentivize this. So for people to actually actively look for wrong chains and to actually come back with the correct chain with more proof of work. Because you can view Utu Relay in a way as storage proof, you can actually query different properties of the Bitcoin blockchain. Yeah, so here we're saying, okay, I want to be sure that there exists a transaction. So for Broly, yeah, we say there exists a transaction where I am the receiver, and then there's this data in the witness field. Then it means for me that I am the owner of this inscription. But you can do a lot more with that. For example, you can do proof of solvency for certain projects, for different kinds of exchanges or dexes, and whatever balance or history or activity you want to know about a wallet. For example, you want some properties of a wallet for airdrops. It would be interesting to hear more from the ecosystem. What could be other good use cases for Utu Relays? Raito is essentially a consensus client written in Cairo, and it implements the same validation logic as Bitcoin Core. What it means that it is an approvable language means for developers that instead of rerunning the whole computation, you can supply a state between two checkpoints. So for example, you can say I went from block number 1 to block 1001 with this logic, so with the correct consensus and transaction execution and so on and so forth, and I ended up at this state, and here is the proof that it has been done correctly. And the verification of this proof happens faster than the re-execution of the calculation. So this actually has nothing to do with Bitcoin or anything. These are just properties of Cairo as the language and the Stark protocols. Yeah, so this can definitely be used to compress this heavy computation that Bitcoin assumes and expects from the nodes. So I believe that syncing nodes faster could be a great use case to invite more people to support the security of the ecosystem. Ord is a CLI that has been developed to work with the latest upgrades to Bitcoin, which is Taproot. Yeah, so it allows you to create inscriptions, to send them, to create runes, to burn them, and I invite everyone to try out Ord and see what you can do. So you can manage your wallets and balances, do a lot of things. Yeah, it's a very nice library. It's and it's got a very supportive Discord. So I really recommend if you want to run the Ord server and you want to index the Bitcoin blockchain, I really recommend not doing it from scratch, but to download the database that gets updated, I think, every couple of weeks. And you can do it in the Ord, but it can inspire a lot more than just what we do with Broly, because with Broly we just do, one inscription, but maybe it could inspire more about secondary markets or other activities that you can do with inscriptions.
So here's the link to the project if you want to deep dive into how Broly works and how it makes use of these dev tools. Here you have Raito, and you also have Utu Relay. So all the links are here for you to dive into how these tools work. And we invite you to do some experimentations with them, to play around, to see what kind of ideas you can come up with when it comes to building an application on Starknet that makes use of the Bitcoin ecosystem. So just as an overview, what we did here, we gave you an overview of how Broly works, how we built this application on Starknet that interacts with the Bitcoin ecosystem. We showed you the demo of how to actually create that inscription. And then Lana created that lemon emoji inscription and sent it back to my Bitcoin wallet. And lastly, we also told you about Uto Relay, about Raito, and all these dev tools that you need in order to create these applications. That's it for the tutorial. Lana, thank you so much for all the explanations and all the details, and we'll see you in the next one.
Thank you, Victor. Bye-bye, everyone.
See you.